Hello, I'm Jared and welcome to doingscience.org. This lesson is called Paperclips and Parachutes. It connects to the Physical Science Core Idea 2A, Forces in Motion. This video and our teacher instruction page to the right of this video will explain how to do this lesson and give you the science background to feel confident when presenting this lesson to your students. The big idea in this lesson is that each force that acts on an object has both a strength and a direction. The force of gravity will pull the paperclip down to the ground, while the air the paperclip's traveling through pushes up against the paperclip in the opposite direction. We can increase the up force by attaching a parachute to the paperclip and slowing down the speed of the paperclip. At the beginning of this lesson, you will be talking and demonstrating to the whole class. Here are the materials that you'll need for each setup. A larger paperclip, a napkin, 4 pieces of string. Each piece should be about 50 centimeters long. Tape, scissors, a centimeter ruler, and a stopwatch. If you need a centimeter ruler or a stopwatch, we have them linked to the right of this video. In the beginning, as a class, we want to determine about how long it'll take the paperclip to fall and hit the ground. I'm here on a chair, ready to show you how we're going to drop the paperclip. You're going to want to hold the paperclip about chin height and drop it. You'll also want to have a student volunteer with a timer ready to time it. You'll find it takes about 0.5 or 0.5 of a second to hit the ground. And if you don't have the timer, we have one to the right of the video. It's important for them to realize that scientists like to record and measure science events to find patterns. Now it's time to engage the students. Break the students into groups of 3 or 4 and give them the measurement page to the right of this video. Now the students will practice timing the fall of the paperclip alone. Let them practice for a few minutes. We've found that for this lesson, student jobs should remain the same for the entire lesson. One person is always the timer, another person records, and 1 or 2 of the students release and recover the paperclip. Once everyone knows their job, have each group time how long it takes for the paperclip to fall and record the time for 10 trials. Record these times into the first column of the measurement page. We like this Micron stopwatch. It's simple and easy to use. You'll need a stopwatch that takes the time to at least in tenths of seconds. Remember, there is an online stopwatch to the right of this video, and many cell phones have a stopwatch function. After students have finished recording how fast the paperclip falls 10 times, have them briefly examine some of the results of the other groups in class. You might also want to have them find the average. For the next part of the lesson, each group will construct a parachute. This parachute will then be attached to the paperclip, and again, students will time how long the paperclip takes to fall to the ground. Here is how to make the parachute. We start with a napkin. Any size napkin will work. And the neat thing about most napkins, when you open them up, you'll find that they are actually 2-ply. That means 2 pieces. You only need 1 ply, 1 piece. You can get rid of the second one or give it to another group. It's up to you. Now I need to attach a piece of string to each corner of the napkin. So I'm just going to lay this out. Again, the thickness of the string is not super important. You know, kite string would work. You do not want a huge piece of tape going on at each corner. A little piece of tape just to hold the string onto the napkin works fine. Tear it off and attach. To the third corner. You don't have to rush. You do want to try and keep the string to be about the same length. In other words, have the same amount of string overlapping the corners. A little long there. And we're ready for our last corner. There we go. Now we need to attach this to the paperclip. So grab it in the middle. Dangle all the strings down. You don't have to crumble the parachute. What I want to do is put a simple overhand knot close to the end of the strings. Make sure I have them grouped. Come around through. Nothing pretty. And now I'm going to trim the end with my scissors. And I'm ready to attach the paper clip. For this, I want to just open the paper clip a little bit, and I'm going to slide it down the knot. And I am ready to see how this thing flies. Now we're ready for our test flight with the parachute, so you know what to expect. Remember, when releasing this, you need to hold this high so that the paper clip is about at my chin height. And release and watch her drop. Once each group has made their parachute, let them practice for a while. If the parachute hits a chair or table on the way down, don't count that trial. Have the students try again. Students should record each of their 10 trials in the second column. Now students will explore by changing the parachute in some way and predicting what effect this change will have on the time it takes the paperclip to reach the ground before they do the trials. Here are a few suggestions. Perhaps they can add extra paper clips to the parachute. Perhaps they can cut a hole in the parachute. Perhaps they can make a smaller parachute or a larger parachute. Perhaps they could use both layers of the napkin or the parachute. Have students predict what will happen before they do the trials, maybe even on the sheet. And once they make their prediction, have them do 10 trials to see if their prediction was true. Don't worry if a student idea seems as if it will not work. In science, even an unexpected answer helps us learn. Once all the trials are finished, have students calculate the average for each column. Have groups compare the averages to each other and have a discussion about how each group changed their parachute and the effect it had on the speed of the paperclip. Finally, research about learning science encourages students to write about their experiences. Have students conclude and reflect at the end of a science experience. Please take a look at our writing prompt to the right of this video and consider using it at the end of the lesson. And have your students write about what they have learned. If you would like to extend the concepts in this lesson in other ways, check out our highlighted interactives for forces and motion. From learningscience.org, number 6 and number 7 connect well to this lesson. And some age-appropriate books from Amazon, both links to the right of this video. Thanks for watching, and explore doingscience.org for more engaging and relevant science lessons for your students.